Assalamualaikum and very good evening to Professor Dr. Alimran. So my name is Muhammad Kakimi. My contact number is CD240067 and today I'm going to present about our group project. So our title is about analysis of elemental defects due to load variation on library bookshelf. So we are from group 85. So we have a total of five group members. Three of us are men and the other two is women. So the first one is our lead, which is Muhammad Ansar. The second one is myself, Muhammad Taufik Hakimi. The third one is Muhammad Akram Nuruddin. And the fourth one is Nurul Sofiani. And the last one is Nur Atika Kamalia. So let's move on. So this is our introduction for our group project. A library shelf function as a structural member where the weight of books acts as a uniformly distributed load. This load is transferred to vertical support as reaction force, maintaining static equilibrium. The shelf integrity is evaluated using the flexure formula, which relate to the maximum bending moment and moment of inertia to internal bending stress. And to ensure the design is both safe and functional, the material must resist this stress without exceeding its elastic limit while also meeting serviceability, deflection standards, or a factor of safety is applied to account for material and loading uncertainties.
So lastly is about our theory. So the structural integrity of library shelving depends on the interaction between loading pattern, point load, and uniformly distributed load (UDL). And lastly is material response. While point load causes localized deformation, UDL poses a greater risk for long-term deflection and serviceability failure. In high traffic environment, repetitive stress can lead to fatigue failure, where metal cracks propagate even below material yield strength. Performance is further dictated by material selection. Isotropic plywood varies in strength based on grain direction, where might still offer superior stiffness but require bracing to avoid localized yielding. Ultimately, maintaining stability requires balancing bending moment and internal stress to prevent joint wear and catastrophic failure.
Hello, my name is Nur Atika Kamalia, and today I will present about methodology. To ensure the bookshelf structurally sound, we perform a series of engineering analysis using 7 formulas. For the first one is distributed load. We calculate the distributed load omega, which is the total weight divided by the length. Second is reaction force. We find the reaction force R by multiply omega by the length. The third one is bending moment. To understand the stress on the shelf, we calculate the maximum bending moment M using the omega times length square all divided by 8. Then moment of inertia, we determine the resistance to bending I by taking the base times the head cube divided by 12. Next, bending stress. The axial stress sigma is found by multiply the bending moment by the distance from the center y and divided by the moment of inertia. Next, deflection. We calculate the sagging or the delta using omega times length to the fourth power divided by 8 times the elastic modulus and the moment of inertia. And the last one is factor of safety. We ensure safety by dividing the material's yield strength by our calculated stress. On the right, we have defined the dimension of bookshelf. The main structure consists of a side panels, top and bottom section, and the individual shelf, all construct from 20 mm thick plywood. For the back panel, we choose 5 mm MDF to provide the stability without adding unnecessary weight. This dimension was chosen to optimize the ratio between storage space and structural stability. The accuracy of our calculation depends entirely on the material consists we use. These tables summarize the material properties used for our analysis. We analyzed 3 primary materials. The first one is plywood for the shelf, MDF for the back panels, and the third one is mild steel for the support bracket. For the shelving for plywood, it has a density of 600 kilograms per cubic meter and the elastic modulus of 9 times 10 to the power of 9 Pascal. Its yield strength is approximately 35 megapascal. For the MDF, this is for the back panels, we use MDF, which is slightly denser at 700 kilograms per cubic meter, but has a lower elastic modulus of 4 times 10 to the power of 9. Its allowable bending stress is lower between 5 until 2 megapascal. For the mild steel, finally, the bracket, we select mild steel. It is significantly stronger with a yield strength of 250 megapascal and very high elastic modulus of 200 times 10 to the power of 9 pascal, ensuring the support never fails. That's all from me. Thank you.
Assalamualaikum, my name is Ahmad Ansar bin Azman. My matrix number is CD240314. For the calculation, the bookshelf is modeled as a simply supported beam subjected to a uniformly distributed load due to the weight of books. The total load is 147.15 newtons, acting over a span of 0.9 meters. From static equilibrium, the reactions at both support are equal. The maximum bending moment occurs at the midspan and is calculated as 16.56 Newton meters. Based on the assumed cross-sectional dimensions, the maximum bending stress is 0.796 megapascals, which is well below the allowable stress. Therefore, the bookshelf design is considered safe, with a factor of safety of approximately 12.6.
Hello, I'm Nur Shofiani binti Rudi. I will presenting the result and discussion. This shelf was analyzed as a simply supported beam under a uniformly distributed load. A 15 kg book load was applied over a 0.9 meter span, producing equal reaction at both support. The maximum bending moment occurred at midspan with a value of 16.56 Newton meter, resulting in a bending stress of 0.746 MPa, which is well below the allowable stress. The maximum deflection was 0.54 millimeter, also within the allowable limit. Therefore, the shelf is safe and suitable for library use.
In conclusion, this project successfully applied solid mechanics principle to analyze the effect of load variation on a library bookshelf. The critical finding from the analysis is the bending stress remained within the allowable limit. However, the deflection was identified as a governing serviceability condition for the shelf design. In terms of safety, the calculated factor of sector confirmed that the bookshelf is safe for normal library users. Overall, this study demonstrates the structural analysis is essential in furniture design to ensure durability, reliability, and long-term performance. Based on the result and discussion, several recommendations can be proposed to further improve the structural performance of the bookshelf. First, the stiffness of the shelf can be increased by increasing the shelf thickness, reducing the span length, or adding intermediate support to minimize deflection. Secondly, materials with higher modulus elasticity may be considered to enhance rigidity and long-term durability. Lastly, implementing load limit guidelines and conducting further studies such as finite element analysis and experimental testing will help to validate and improve the current design. That's all from me. Thank you.